only have a resistor and an inductor. These three components are the same. If you know the expression for XL or XC, I will first calculate capacitive reactance. Since inductance is given, first to XL, then impedance, then IRMS. Then let us look on for what has to be calculated. The current flowing through the circuit. Now comes the specification. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. So in my previous session, we started discussing numericals on the chapter Alternating Current. And as I've clearly told you, question number 35 in the paper is 90% of the times from this chapter. So I hope you have practiced yesterday's sessions. You have solved those numericals again. If you have done so, today's session will again be beneficial. So we again start discussing problems from the chapter today. Now the first problem says there is an inductance of 2 Henry, an inductor of 2 Henry, a resistance of 10 ohms connected to a 220 volt 50 hertz AC supply. Inductor of 2 Henry, resistance of 10 ohm. It is connected to 220 volt 50 hertz AC supply. Gamansi, one of the component is missing. Good. There is no capacitor connected in the circuit. So such circuits are called RL circuits, where I only have a resistor and an inductor. Given so, first I have to calculate impedance of the circuit. Second, I have to calculate current in the circuit. Third, I have to calculate power factor. And fourth, phase difference between voltage and current. So first step ಏನು ಮಾಡ್ತೀವಿ ನಾವು problem solve ಮಾಡಬೇಕಾದ್ರೆ? Yes, we collect the data. So first we will write down the data. So what is given here? Inductor 2 Henry, 2 Henry inductance present ಇದೆ, resistance 10 ohms. ಈ ಅಪ್ಲೈಡ್ EMF ಏನ್ ಕರೆದ್ವಿ? ಅಪ್ಲೈಡ್ ವೋಲ್ಟೇಜ್ ನ ವೆರಿ ಗುಡ್ VRMS ಅಂತ ಕರೆದ್ವಿ. ಸೊ V RMS is 220 volt and frequency is 50 hertz. Now with this data given, first he is asking us to calculate impedance of the circuit. ನೀವಿಲ್ಲಿ ಏನು ನೆನ್ಪಿಟ್ಕೋಬೇಕಂದ್ರೆ ಇಂಪಿಡೆನ್ಸ್ ಕಂಡು ಹಿಡಿಯೋಕ್ಕಿಂತಲೂ ಮುಂಚೆ ನಾವು ಕ್ವೆಶ್ಚನ್ನ ಅನಲೈಸ್ ಮಾಡಿದ್ದೀವಿ. ಅಲ್ಲಿ ಇಂಡಕ್ಟೆನ್ಸ್ ಮಾತ್ರ ಇದೆ ಅಂತ ಗೊತ್ತಾಯ್ತು. ಫಸ್ಟ್ ಕ್ಯಾಲ್ಕ್ಯುಲೇಟ್ ದ ಇಂಡಕ್ಟಿವ್ ರಿಯಾಕ್ಟೆನ್ಸ್. ಅದೇ ಕೆಪಾಸಿಟರ್ ಇದ್ದಿದ್ರೆ ಕೆಪಾಸಿಟಿವ್ ರಿಯಾಕ್ಟೆನ್ಸ್. ಪ್ರತಿಯೊಂದು ಕ್ವೆಶ್ಚನ್ ಅಲ್ಲಿ ಇಂಪಿಡೆನ್ಸ್ ಎಲ್ಲಿ ಕಂಡು ಹಿಡಿಬೇಕು, either XL or XC or sometimes both you calculate easily, you get 1 mark. So therefore, first I will calculate XL. XL is nothing but omega L, where omega L is 2 pi F into L. Alva, omega is 2 pi F. So XL is 2 pi F L. Substitute manana iga. So XL is 2 into 3.14. Frequency is 50. L is 2. So XL is, so on calculation, 2 into 3.14 into 50 into 2, which is 628 ohms. So I am getting XL. So you can see here, 50 into 200, 100 into 2, 200 into 3, nearly 628 ohms. So I have calculated inductive reactance, which is 628 ohms. Now first, I have to calculate impedance. Nene madudvalva. Yen sikkitu namak formula. Z is equal to root of R square plus XL whole square. XC ilvala, XL minus XC whole square, original formula. But capacitance is not there. So R square plus XL whole square. Or this is, what is the value of resistance? 10 ohms. So 10 square plus 628 whole square. So if you observe here, the square root and the squares get cancelled. So approximately 638 ohms is the impedance. ಸ್ವಲ್ಪ ಬ್ರಿಸ್ಕ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಬೇಕು. ಎಲ್ಲಾ ಕಡೆ ಕ್ಯಾಲ್ಕುಲೇಟರ್ಸ್ ಅವಶ್ಯಕತೆ ಇಟ್ಕೋಬಾರ್ದು. ಸ್ಕ್ವೇರ್ ರೂಟ್ ಅಂಡ್ ದ ಸ್ಕ್ವೇರ್ಸ್ ಗೆಟ್ ಕ್ಯಾನ್ಸಲ್ಡ್. 628 plus 10, which is 638 ohms. So I have arrived at the impedance. Second, IRMS, value of current in the circuit. Nene madidnalla in my yesterday session, What is IRMS equal to? Very good. So this is VRMS by Z. So the value of VRMS is 220 divided by Z 638, which is 0.344 amperes. 44 amperes. Impedance siktu. Current in the AC circuit is got, which is nothing but IRMS. Next, he is asking us to calculate power factor. So we know power factor cos phi is always R by Z, or cos phi R is 10, Z is 638. So cos phi is equal to 10 divided by 638 divided by 638, which is 0.0156. Any unit for cos phi? Power factor? No, it is just a number, factor. And finally, phase difference phi, which is cos inverse 0.0156. This is an assignment for you. Look at the log table and you get the answer. So with basic descriptions, see how easily I have arrived at the value of impedance, current, VRMS by Z, power factor, cos phi, which is R divided by Z, and the phase difference, cos inverse of whatever value you have got. Proceeding next. Beautiful again. A 80 ohm resistor and a 20 microfarad capacitor are connected in series. Gaman 80 ohm resistor, 20 microfarad capacitor are connected in series with an AC source of 220 volts, 50 hertz. AC source of 220 volts, 50 hertz. I have to calculate potential difference across each one of them. Now again, students, potential difference across each one of them. Andre, across the resistor and across the capacitor. ಇಲ್ಲಿ ಗಮನಿಸಿದ್ರೆ ಏನ್ ಅನಲೈಸ್ ಮಾಡ್ತೀವಿ? ಇಂಡಕ್ಟರ್ ಇಲ್ಲ, ಇಂಡಕ್ಟರ್ ಬದಲು ಕೆಪಾಸಿಟರ್ ಕೊಟ್ಟಿದ್ದಾರೆ. ಸೊ ವೆರಿ ಕ್ಲಿಯರ್ಲಿ ದಿಸ್ ಈಸ್ an RC circuit. You can build such circuits without an inductor, without a capacitor. Now again, I will fetch data here. Now, the resistance is 80 ohms. Capacitance is 20 microfarad. Again, take note of that. Micro, 10 power minus 6. AC source, again, VRMS value is 220 volt and the frequency is 50 hertz. Now students, anywhere where you want potential, current, first I will calculate the impedance. Impedance of the circuit. Previous problem and ಏನು ಹೇಳಿದೆ? ಎಲ್ಲಿ ಇಂಪಿಡೆನ್ಸ್ ಬೇಕು ಅನಲೈಸ್ ಮಾಡಿ ಡೇಟಾನ ಫಸ್ಟ್ ಕ್ಯಾಲ್ಕುಲೇಟ್ ಐದರ್ XL or XC. Since this is an RC circuit, I will first calculate capacitive reactance. So all of us know capacitive reactance is 1 by 2 pi FC, 1 by omega C, so it is 1 by 2 pi FC, and C is 10 power minus 6. Therefore, when we substitute, do the substitution, this turns out to be 159 ohms. Take your calculator, simple, 2 into 3.14 into 50, substitute for C, 20 into 10 power minus 6, ಮಾಡಿ simplification na, XC turns out to be 159 ohms. Now first, I'll calculate the impedance. Now this is root of R square plus XC whole square. Capacitance alva, inductor illa iga, absence of inductance. So Z is root R square plus XC whole square. Previous problem, there was inductor, so R square plus XL whole square. Now I have a capacitor, R square plus XC whole square root. So this is equal to, again, what is the value of R? 80. So this is root 80 square plus 159 square. So this turns out to be, again the square root and the squares get cancelled. So we have 80 plus 159, which is 239, nearly 178 we get. So when we simplify 80 square plus 159, you get nearly 178 ohms. So do the simplification, you get this. So impedance is calculated. Next, so 80 square, we'll cross check it again. So 80 square will be 80 into 80. So 6,400. This is just for cross checking. Plus 159 into 159 is 25281, the whole square. So plus 6400 is so much. The whole square is 178 ohms. So now, again, IRMS is VRMS by Z. So VRMS is again 220 divided by 178, which is 1.23 amperes. Follow, this part of the calculation is pretty the same for any problem we take up. Calculation of either XL and XC, calculation of impedance of the circuit, calculation of the current flowing through the circuit. Now comes the specification. I have to calculate the potential difference across each component. So first I will calculate potential difference across the resistor. So I call it as VR. Ohm's law has said V is I into R. I is nothing but this IRMS value. So this is 1.23 into resistance is 80. So we have 1.23 into 80, nearly 98 volts. And what is VC? Resistance across the capacitance. Current will be the same. Now, instead of R, what will you write? Resistance offered by the capacitor. Good. Capacitive reactance. If it was an inductor, I into XL. So this is 1.23 into XC is 159. So now we have 1.23 into 159, which is 195 or nearly 196 volts. So points to remember here, when you calculate the potential across the capacitor, it is I into XC, basic form of Ohm's law, I into R. Resistance of a capacitor is XC, resistance of an inductor is XL. Next one. A coil of inductance 30 millihenry. Inductance idega 30 millihenry and a resistance of 15 ohms are connected in series with a source 220 volt 50 hertz. If this part of the question is given, automatically it means you are aiming to calculate XL, impedance and current in the circuit. Now comes the specification. Calculate the average current in the circuit. Peak current alla. Average current has to be calculated in the circuit. Now, again to take up with the data, inductance is 30 into 10 power minus 3, which is 0.03 Henry. Resistance is 15 ohms. VRMS and the frequency as the same. Since inductance is given, first to XL, then impedance, then IRMS. Then let us look on for what has to be calculated. So first, XL, which is 2 pi FL, 2 into 3.14 into 50 into 0.03, which is, so when we simplify, 2 into 3.14 into 50 into 0.03. So it is around, 17. Again, 2 into 3.14 into 50 into 0.03. So on simplification, it turns out to be 9.42 ohms. So XL is calculated. I get the value of XL as 9.42 ohms. Next time kandiditira. Impedance. Z is root R square plus XL whole square. Capacitance ilvalla. Root R square plus XL whole square. This is, again, what is the value of resistance? 15 ohms. So root 15 square plus 9.42 whole square. On simplification, 225 plus nearly 81 root. So it turns out to be 17.7 ohms. So XL is calculated. Z is calculated. Impedance. Good. So IRMS, which is again VRMS divided by Z. So VRMS is again 220 divided by 17.7, which is nearly 12.42 ampere. See, the same initial calculation of XL, same initial calculation of impedance, same initial calculation of the IRMS. Now coming to the specification where I have to calculate the average value of current. So we know I average is 2 by pi times I naught. See, this is the reservoir. To solve this specification, I require the reservoir. I average is 2 by pi times I naught. What is I naught? Peak value of current. I naught kande aata mugit. Adra I naught yav riti kandidile. Mr. IRMS is here. So very clearly, IRMS, how do you relate IRMS and I naught? So we know I naught is IRMS into root 2. IRMS is I naught by root 2. So I naught is IRMS into root 2. 12.4 into 1.41. So when I substitute into 1.41, so this is, so 12 0.4 into 1.41, which is 17.84 amperes. And finally, therefore, average value 2 by pi times I naught, and final substitution will be done by my students. Nodi, adane heliddu. These three components are the same. If you know the expression for XL or XC, impedance, IRMS, 3 marks is obtained. To go for the specification, you require the theory. So simple concepts tilkode, you can solve. Fourth one, very interesting. A capacitor and a resistance of 20 ohms are connected in series. See, very nicely he says, there is a capacitor whose value is not known. Resistance of 20 ohms are connected in series with a 220 volt, 50 hertz AC supply. Same thing. Find the value of capacitance required to make the power factor equal to 0.6. I have to find the value of the capacitance, so the power factor is 0.6. ಗಮನಿಸಿ ಮಕ್ಕಳೇ, ಪವರ್ ಫ್ಯಾಕ್ಟರ್ ಕೊಟ್ಟಿದ್ದಾರೆ. cos phi is 0.6. Phi is cos inverse 0.6. Your log table says it is 53 degrees 8 minutes. Capacitance value ಕಂಡುಹಿಡಿಬೇಕು. ಸರ್ ಏನಕ್ಕೆ phi phase angle ಕಂಡುಹಿಡ್ಕೊಂಡ್ರು? Do I know the expression for tan phi? Very good. So we know tan phi is equal to XC by R. ಯಾಕಂದ್ರೆ ಇಂಡಕ್ಟರ್ ಇಲ್ಲ. XL ಮೈನಸ್ XC by R ಬರೆಯೋದಿಕ್ಕೆ ಇಂಡಕ್ಟರ್ ಆಬ್ಸೆಂಟ್, ಕ್ಲಾಸ್ಗೆ ಬಂದಿಲ್ಲ. So absent ಮಾಡ್ಬಿಡೋಣ. So tan phi is XC divided by R, which means tan phi equals XC andre 1 by 2 pi FC. So this entire term goes to denominator. ಈಗ ಗೊತ್ತಾಯ್ತಾ ಯಾಕೆ phi ಕಂಡಿಡ್ದೆ ಅಂತ? C substitute ಮಾಡ್ಕೋಬೇಕಷ್ಟೇ. So C is 1 by 2 pi F R into tan phi. ಸುಲಭ ಆಯ್ತಾ? ಹೇಳ್ಕೊಟ್ಮೇಲೆ ಎಲ್ಲಾನು ಸುಲಭ, ಕಲಿಯೋ ತನಕ ಮಾತ್ರ ಕಷ್ಟ ಅಲ್ವಾ? So C is 1 by 2 into 3.14 into 50 into resistance value 20 ohms, 20 into tan 53 degrees 8 minutes. Simplify Madi. When you simplify, this is nearly 12 microfarad. The simplification you should be sincere enough in doing. The last one, I will give a hint, you will have to solve. Inductance of 0.2 henries, resistance is 40 ohms. ಕೊಟ್ಟಿದ್ದಾರೆ. power dissipated in the circuit. So, all of us know power dissipated is given by the formula VRMS IRMS into cos phi. Please do know this formula. Power dissipated in any AC circuit is VRMS into IRMS into cos phi. VRMS ಕೊಟ್ಬಿಟ್ಟಿದ್ದಾರೆ 220 volts. IRMS ಕಂಡುಹಿಡಿಯೋದು ಹೇಳ್ಕೊಡ್ಬೇಕಾ? ಎಲ್ಲಾ ಪ್ರಾಬ್ಲಮ್ ಅಲ್ಲೂ ಮಾಡಿದೀನಿ. First impedance root of R square plus XL whole square. So IRMS is equal to VRMS by Z. VRMS ಸಿಕ್ತು, IRMS ಸಿಕ್ತು, ಉಳ್ಕೊಂಡಿರೋ ಬಾಂಡ್ ಯಾರು? cos phi. So what is cos phi equal to? R by Z. ಮೂರು ಕ್ಯಾಲ್ಕುಲೇಟ್ ಮಾಡಿ ಅಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿ, you will get the power dissipated. So if you are observing the calculations, there is a common pattern that is followed in the problems. XL or XC, impedance, current, then whatever is required. In my next session, I will arrive at problems which are of slightly higher degree complex. Until then, practice these sessions. Again and again you practice. These are the 5 markers which will appear. Have a nice time. Thank you.